So today we're going to be looking at doing two different topics at the same time because the topics individually are quite small. First one we're going to be looking at is sample space diagrams, and then afterwards we're going to be looking at doing some two-way tables. So a sample space diagram is very similar to what we were looking at earlier this week when we were looking at combinations. It kind of tells us how many different possible outcomes there are. The difference with a sample space diagram is there could be kind of a repeated outcome, especially if we're thinking about picking counters out of a bag, which we're going to look at in a second. Those repeated outcomes, they count as different individual ones, so we do have to count them multiple times, but we'll look at an example of that pretty much straight away actually. So here's the first question we're going to be looking at. It says bag A contains 3 red counters and 2 blue counters and also 1 green counter. We've got bag B, which contains 2 red counters, 1 blue and 2 green counters. And it says a person's going to win this kind of game if they pick a counter out of each bag and the colours are the same. And the first thing we need to do is draw a sample space diagram to show all the possible outcomes and then actually find the probability that this person wins. Okay. So just to help us out here, what I'm going to start off by doing is I'm going to draw 2 bags. We'll call this one bag A and this one bag B, and we'll put some counters in there. So the first bag needs 3 reds. The second bag needs 2 reds. This bag needs 2 blues. This bag just needs the 1. And then this one needs 1 green and this one needs 2 greens. So we're going to take a bag. So we're going to take a counter out of bag A, and then we're going to take a counter out of bag B, and hopefully they are going to be the same colour. That's how we win the game. So you might look at it and think, well, maybe we've got a good chance. We've got what looks like a 3 out of 6 chance of a red, and if we pick a red there, we've got a 2 out of 5 chance of getting a red in that one. If we pick out a blue, okay, that one's probably the worst possible combination. And if we're unlucky enough to get the green over here, at least we've still got a decent chance of picking out a green one in bag B. So let's just put the question over there. And we're now going to draw the sample space diagram. Okay, so to do these, what you need to start off by drawing is a little table that looks something like this. And we're going to put all the possible outcomes for bag A, maybe across the top, and all the possible outcomes for bag B along the bottom. Now, the thing we have to remember here is if, like we can see in bag A, if we have more than 1 red counter, we need to put more than 1 red along the top. So the things that could happen from bag A is we could get a red, or a red, or a red, or a blue, or a blue, or a green. And then in bag B, what we could get is a red, a blue, a green, or a green. And then all we're going to do now then is to finish off the sample space, we're just going to write the combination of letters if I was to pick one out of bag A and one out of bag B. Now there's no particular way that we need to write it. I'll put the bag A letter first, followed by the bag B one, just to kind of be consistent throughout here. So this one would be a red followed by a red. This is also a red followed by a red. This is also a red followed by a red. This would be a blue, then a red, a blue, then a red, and this would be a green, then a red. Okay, so you can see already the red answers here, these are our final outcomes, and we are getting repeated outcomes. That's because we could technically have different combinations of picking a red out of bag A and a red out of bag B. This second line is just going to be exactly the same as the top one because it's still picking a red one out of bag B. And now we're going to get red followed by a blue, red followed by a blue, red followed by a blue, blue and a blue, blue and a blue, a green, then a blue. This is red and a green, red and a green, red and a green. This is a blue, then a green, This is a blue, then a green. This is a green and a green. And this line is going to be exactly the same because it's also picking a green out the second time. And this is my completed sample space. Okay, we can see that there are 30 different possible outcomes here. And some of them, or quite a lot of them, are actually the same. But that means any probabilities that we're going to be working out, especially in part B, they're going to be out of 30 because there are 30 different red combinations that could actually happen. So here's part A done. So part B says, what is the probability that we win the game? So in order to win the game, we need to get the same color twice. So red, red is a good one. Red, 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 red. There's another red, 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 red. Next line, blue, blues are fine, same color. And then we want green, green, and green, green. So we have got 10 possible combinations where we could win out of 30 different combinations altogether. So that gives us, if we were to simplify it, a 1 in 3 chance of actually winning the game. So even though it looked quite like it was going to be a likely outcome of picking two of the same colour, one from bag A and one from bag B, it's actually only a 1 in 3 chance of winning this particular game. The key thing here is it was this thing at the bottom left corner. This was the sample space. So if it asks you to draw a sample space, this is what you need to actually draw down. Okay, so for question 2, it's the same idea again, but this time it says we've got 2 fair spinners numbered 1 to 4, and a person is going to spin both spinners, and the score they get is the total of the 2 numbers that their spinners land on. So if we get a 2 and a 3, we're going to score a total of 5. We need to draw a sample space to show all possible outcomes for this one. So same idea, we're going to start off by drawing ourselves a little table. And I'm going to call it spinner 1 up here, spinner 2 over here. So on spinner 1 we could get a 1, a 2, a 3 over 4. And on spinner 2, again it's exactly the same. And this time, rather than writing out the combination, we're not going to write 1, 1, 1, 2, 1, 3. It says we add the numbers together and that's their score. So all we need to do is add the corresponding numbers in the column and the row. Like this. So that's my completed sample space done already. And there would probably be a follow-up question to this. It would say things like work out the probability that you score a 5 or something like that. The final example of, can I change the page? The final type of question that you could get might be where the 2 things are completely different. Okay, so this is quite wordy. So it's in a board game. A person is required to pick a counter out of a bag and roll a 6-sided die at the same time. In the bag, there's 1 blue, 1 yellow, and 1 green counter. If we pick up the blue counter, then the number of spaces we're allowed to move is just whatever number comes up on the die. If we pick out the yellow counter, though, we can add 2 to the number on the die, and we move that much. If we pick out the green counter, we can double the number that appears on the die. Okay, so let's start off by getting this table ready to go. So the 2 different things this time is we've got a bag of counters and we've got the die which we're going to roll. So the counters in the bag were blue, yellow and green, and the numbers on the die are still 1, 2, 3, 4, 5, 6. So if we roll the blue die, the number of spaces that we can move is just whatever number comes up on the dice. Okay, so it's still going to be 1, 2, 3, 4, 5, 6. If we pick out the yellower one, we have to add 2 to the number that's on the die. So 1 add 2 is 3, 2 add 2 is 4, and so on. And if we pick up the green counter, we're just doubling the number that's on the die. So that's 2, 4, 6, 8, 10, 12. And again, that's all we would have to do for these sample spaces. Hopefully these aren't too tricky. You do have a set of questions. And again, it might look like there's a load of questions, but these are not tricky at all. Okay, it is just drawing little tables, filling in the right numbers, and maybe answering a probability question based on your table when you're finished. So that's the sample spaces part done. What we're now going to do is we're going to move on and we're going to look at two-way tables. Okay. Let's get rid of that question. So I'm only going to show you 2 examples of these. These will come up somewhere in your actual exam. Again, if it's going to be an easy question, it will be on the foundation paper as well. And if it's meant to be slightly harder, it'll probably be still at worst around the middle of your paper. So a two-way table just looks like this. It says 80 year 12 students, each study one of the sciences. The table shows some information about these students. Here's an incomplete table. Part A is complete it. And then there's a probability question based on your final table. Okay, and half the time you don't actually need to complete the table in order to work out part B, because if you mess up your answers for part A, you're going to mess up your answer for part B. So this one where it says write down the probability that the student studies physics, we've already got the total number of people who do physics, so we could work out the probability for part B is going to be 33 out of 80 pretty much straight away. I don't think I'm going to do this question because hopefully it's straightforward. You see the totals, you're looking for kind of columns where there's 2 numbers already, or rows where there's maybe 3 numbers to work out a missing one, and it's just a load of addition and subtraction. So you can work out straight away there how many females do physics. That'll give you a number. That will then tell you how many females do chemistry. That will tell you how many males do chemistry. You can see how many people must do biology altogether. That means you can work out how many males will do biology. And if everything's right, then you should be able to work out how many males there are altogether. And then all the numbers should correspond. There are lots of different ways of doing it. There's no kind of one right route of getting the answers. They are really easy if you get them in a table already. On your higher paper, though, what I would suspect is that you get a question that looks a bit more like this one. There is no two-way table already drawn. They would expect you to be able to look at that question and know that this is a two-way table question without having to write the phrase two-way table anywhere in the actual question. So it says 100 students are taking part in a lunchtime activity. They can either do art, music, or drama. Then it starts breaking it down into little parts, and then there's questions based on your final answer. So let's just put the question at the top, and let me draw a table ready. So the 2 things we're going to have on our table here are boys and girls, probably down the side, and along the top we're going to write art, music, drama, and we must make sure as well that we have some total columns. I think I've left myself enough room there. So let's go for boys, girls, total, and then art, music, and drama. And again, we'll put a total at the end. And now we can start filling them in if we just read each line one at a time. Okay, so the first thing it says is there are 100 students. So that we can put straight in the bottom corner. There's 100 altogether. They take part in lunchtime activities. They can do art, music, and drama. No extra information there. 31 students do art. So the total for art is 31. of which 16 are girls. So if you want at this point, you can quickly work out how many boys there would be who do art by doing a subtraction. I'll put that one in. 25 students do music, of which 13 are girls. So similar idea. There are 25 people who do music, of which 13 are girls. So we can work out how many boys must be doing music. And then it says there are 43 boys altogether. Okay, so we now need to try and finish off the table. And again, there's kind of lots of different ways of getting to the final answer. I can see if there's 43 boys, that means there must be 57 girls in order to add up to the 100. I can see that we've got 15, add 12 boys along the top, that's 27. We need to get up to 43, so that must be 16 boys who do drama. Girls, we've got 16, add 13, which is 29. We need to get up to 57. So what's that going to be? That's going to be 28. And then if we add the dramas up, that's going to get us 44. And we can now check along the bottom. So 31 at 25 is 56. 56 at 44 is 100. So I think my numbers there are fantastic. Okay. Now we can answer parts A, B, and C. So this question didn't actually ask us at any particular point to draw this two-way table, but without this table, parts A, B, and C are a little bit tricky. The moment we get this table done, A, B, and C become a piece of cake. Find the probability that a student chosen at random is a boy who attends drama club. So we want a boy who goes to drama, so it's going to be this number right here. It's going to be 16 out of everybody. It's 16 out of 100, which we can cancel down if we need to. Find the probability that a student chosen at random is a girl who attends drama club. So now we're looking at the girl going into drama out of everybody. So that's 28 out of 100. And the last one, you've just got to be careful with the words because it says write down the probability that a girl chosen at random attends music. So parts A and B, we're talking about pick a student at random, and we knew there was 100 students altogether. Part C is phrased so that we are just picking out of the girls. Okay, we are just looking along the girls line. We do not care about the boys at all. So this is now going to be out of 57. Out of the 57 girls, how many go to music? 13. So it's going to be 13 out of 57. We've just got to be careful with those. These are called conditional probabilities. That, though, is as tricky as two-way tables get. So like everything else we've done this week, there is a load of exam questions for you to do. Again, it might look like there's a load of questions, but it is just adding and subtracting, so it really should not take you too long. So there's quite a few pages. There's 2 pages of questions where the tables are already drawn for you. So just get your calculator and fill them all in. And then from question 6 onwards, they are the ones like we've just been looking at. Okay, where there is no table drawn, so you would have to draw your table to get the correct answers. And that is it. That is all we're going to be doing today. So that was a brief talk about sample spaces, and then a talk about two-way tables. Please get this work done. I will be posting answers up probably later on today on Microsoft Teams. So if you're wanting to check your answers, or you think you've got something wrong and you just need a bit of clarification, look on Microsoft Teams at around about lunchtime. The answers will be on there for you to check. Please mark them yourself. Any issues, send me a message and I'll try and help you. If you're still stuck, please use MathsWatch on My Maths to practice a little bit more. But this topic is not a tricky one at all. The sample spaces or the two-way tables. So please get it done, and I will see you all tomorrow for the next part.